All right, so yesterday we found out two things about inverses. First thing we saw is when I look at a table within an inverse, we notice something happened to the x and the y values. Anybody remember what happened to the x and y values in the table? What's that? They switch, they flip, okay? So anytime we're working with inverses, what we're going to notice is that the x and the y value switch. We also noticed something with the graphs. Anybody remember what we noticed about the graphs in those inverses? What kind of transformation?
Line of symmetry.
There you go. There was a reflection. Now the reflection was not across the x-axis.
Oh,
It wasn't across the y-axis. Where was that reflection? It was over the line y equals x, which is that diagonal line, the one that goes from the bottom left-hand corner all the way up to the right. That's right. It's our linear parent function. So what we're going to do is we're going to expand on what we talked about yesterday, and we're still looking at those inverses. So here we go. Number one, they give me the equation y equals 1/2 x plus 3. And what they want me to do is complete the table using this equation. Now, I don't want you to use your calculator. As a matter of fact, I want you to turn them off and put the lids on your calculator right now. We're all smart enough that we can do this without a calculator. We can do this in our head. I believe you. You're that smart. You're that smart. All right, so here we go. What I want to know is, what is the y value for this equation when the x value is a -4? Well, think about it, guys. Here's what we're doing. First thing we're doing is taking half of this -4 here. What is half of -4? -2. Let's take that -2 and add 3. So what's a -2 plus 3? 1. So that's the y value. It's a 1. Let's do that again. Let's use a -1 this time. Half of -1. What's half of -1? -0.5. And what's a -0.5 plus 3? 2.5. 2.5. That's the next one. 0. Half of 0. Half of 0 is 0. And 0 plus 3. 0 plus 3 is 3. Next number is 3. Half of 3. Half of 3 is 1.5. And 1.5 plus 3 is 4.5. 4.5. One more here. 6. Half of 6. Half of 6 is 3. And 3 plus 3 is 6. So see, that wasn't as bad as you thought. Where it's going to get a little tricky is the next two. Because this time what they did was they gave me the y values rather than the x values. So the process we go through is going to be a little bit different. So what they've done is they give us some room here to show our work. So we're going to start with this 13 here. What is the x value when the y value is 13? So notice what they've done here. They've replaced this y here with the number 13. What we're going to do is figure out what the x is. You're going to help me out with this. So here we go. We have the equation. 13 is equal to 1/2 x plus 3. Let's go back to your Algebra 1 days. First thing I got to do is what? Let's solve for it. First thing we got to do is subtract 3. Now make sure you show your work just like I'm doing on mine. Show all of your work. By the way, when you're working with the equation, we always know whatever I do to one side, you also have to do it to the other. So when I subtract 13 minus 3, I'm going to get a 10. Which means now I have 10 is equal to 1/2 x. Am I done? No. What do I got to do next? We're going to multiply by 2. Because the opposite of taking half of something would be to double or multiply it by 2. 2 times 10. 2 times 10 is 20. And of course that 1/2 and 2 leaves me with 1x. So the x is 20. That's what I'm going to put in my table over here. When the y value is 13, the x value is 20. Let's try that again. This time they give me a 47. I want to know what is the x value when the y value is 47. So let's do that again. First thing we're going to do is subtract 3. So 47 minus 3. 47 minus 3 is 44. So now what I have is 44 is equal to 1/2 x, but that's not the answer yet. What did I do after that? Multiplied it by 2. When you multiply 2 times the 44, what you're going to get is 88. And of course, 1/2 times 2 is 1x. Therefore, the x value over here is 88. So in order to find the last two, the process I went through was a little bit different. I had to subtract 3, then I had to multiply by 2. All right, we've got the table filled out. Let's move on here. Number 3 says, in the original function, imagine if we were to switch the x and the y variables. If x and y are interchanged, the new equation would be x is equal to 1/2 y plus 3. They want us to solve this equation for y. So let me show you what they did there. Here's the equation that we started with, right there. What they did was they took this equation, took the y and the x, and had those two guys trade places, which is how we came up with this new equation here. So it's the same thing. All we did was switch the x and the y. So here's what we're going to do. We're going to take that equation, and we're going to solve it for y. Solve it for y? How the heck do you do that?
Well, you would get the.
Let's get the y.
Okay, and how do I do that? What do I do first? Okay, and what number am I going to move over first? Huh? Well, not plus 3.
Or
It's
negative.
What's
going
the
to be
opposite?
negative.
Okay, we're going to actually do the opposite. Opposite of plus 3 is minus 3. So we're going to start by subtracting 3. We're trying to get y by itself. So x minus 3 is simply x minus 3. Over here I've got 1/2 y. But that's not the answer. I got to do one other thing. What's the other thing I got to do here? Multiply by 2. Now we need to be very careful here, guys. When we're multiplying by 2, we're actually multiplying the whole side by 2. So I'm going to put this x minus 3 in parentheses. I'm going to multiply the whole thing times the 2, which means I'm going to have to use some distributive property here. 2 times the x. 2 times the x is 2x. 2 times the negative 3 is negative 6. And over here, all I'm left with is y. So I've got a brand new equation, and that brand new equation is y equals 2x minus 6. There's our new equation.
Let's check it out.
What's that? Well, we multiplied it by 2. Remember this 2 right here? We multiplied that 2 with that 3. When you multiply 2 times 3, you get this 6 right here. That's what happened. All right, so there is our new equation. Now, on number 4, they want to know how is the process that we did in question number 2 alike to what we did in problem number 3. They're the same. Notice what we did here. We started by subtracting 3, then we multiplied by 2. Isn't that the same thing we did over here? We subtracted 3, then we multiplied by 2. So the process is exactly the same. So that's what I want you to write down for me here. How was the process used in 2 and 3? They're the same. We subtracted 3, then we multiplied by 2. We subtracted 3, then we multiplied by 2. Subtracted 3, then multiplied by 2. All right, so here's what we're going to do next. We're going to take that original function they gave us, which was y equals 1/2 x plus 3, and we're going to graph that thing on our graph paper. Now, don't get your calculators, because again, all of us should know this equation we're working with is in slope-intercept form. It's in this form right here. And everybody still remembers that M stands for what? Slope. The B stands for the y-intercept. So we're going to use that to our advantage so we can get it correct. So here we go. Benito, what's the y-intercept in the equation y equals 1/2 x plus 3? Which one of those numbers is the B, the y-intercept? Positive 3. So what we're going to do is we're going to come over here to our y-axis and put a point at positive 3. All right, James Luna. Next thing I need to know is what is the slope? What is the slope of this line? 1/2, which means I need to do what? Go up? How many? No. Let me remind you guys, slope is rise over run. So let's try this again, James. How much am I going to have to go up? Look at the fraction. Look at the 1/2. What's the top number? 1. So that means I'm going to have to rise 1. What's the bottom number? What's this bottom number here? 2. So what is that telling me? That I have to run 2. So I'm going to go up 1, 2 to the right. So let's go ahead and do that. On my y-intercept, I'm going to go up 1, 2 to the right. Now, I'd like to have more points than that. 2 dots is not quite enough to get a nice straight line. So what can I do to get some more points on here? Mike, what can we do? I want more points. What can we do so that I can get a nice straight line? What's that? Repeat it. Now, when you say repeat, you're saying repeat going up 1 and over 2. Okay, that's what we're going to do. We're going to go up 1, over 2. Up 1, over 2. We can keep repeating the process. As a matter of fact, I can even get more points over here by doing what?
Going to the left.
All right, going down 1, to the left. Down 1, to the left. Down 1, to the left. The more points you have, guys, the straighter that line is going to be. Once you have all your points, connect all those dots for it. So what we've just done is graph the equation y equals 1/2 x plus 3. That's what we've done. Now what we're going to do is we're going to graph that new equation that we came up with. All right, so Melinda, what was that new equation that we had? We just came up with a new equation. What was it? Y equals what? We just did. We just came up with a new equation. 2x minus 6. So what we're going to do is we're going to graph that 2x minus 6. All right, so let's see here. James Luna. Y-intercept. What is the y-intercept of our new equation? Negative 6. So let's find a negative 6. 1, 2, 3, 4, 5, 6 right here. The next thing I need is the slope. So what's the slope there? Positive 2, which means I need to do what? Go up how many and over how many? You're right, the slope is 2. Go up 2, 1 over, and 1 over. All right, we're going to go up 2, over 1. Up 2, over 1. Remember, the more points you have on here, the better your line's going to be. Once you have all of those points, connect the dots. And here's our new graph. So that graph I have there is for the equation y equals 2x minus 6. All right, so let's take a look at these two graphs. Number 6 wants to know, what do we notice about these two graphs? So, Lanisa, what do we notice about these two graphs, Lanisa? Think about what we said yesterday when we were graphing these inverses. What happened yesterday? Well, not over the x-axis. You're right when you say reflection, but it wasn't over the x-axis. Nope, not that one either. Y equals x. It was this line that goes diagonal. Okay. That's what we said yesterday. So, Lanisa, did we see that again today? Did we see a reflection across the line? Yes, we do. Okay, so for number 6, what we noticed here is the same thing that we noticed yesterday, which is we have a reflection across that line y equals x. Same thing as yesterday, guys. We're seeing a reflection across that line, y equals x. As a matter of fact, I want you to draw that line for me as well. Notice I'm using a dashed or dotted line. This way I don't confuse it with one of my other lines. draw it for me as well. Draw that line of sight. Okay, number 7, how are the inverse relations connected to inverse operations used to solve the equation? Now they give us a real detailed explanation, but basically all I want you to do is write down that the process was the same. Process is the same. In other words, we started by subtracting 3, and then we went and multiplied by 2. Process is the same. We multiplied by 3. I'm sorry, we subtracted 3, then we multiplied by 2. The process is the same. All right, we're over on the next page. Over on the next page, they give us a function. In a little while, we'll be finding the inverse of that function. We'll be creating a table for each of these functions. And then we'll also be graphing both of these functions. But we're going to start pretty easy here. We're going to start by graphing y equals 2x minus 4. Again, we still don't need a calculator. We can do this. So, April, what is the y-intercept on this graph here?
-4.
-4. So we're going to start over here at -4, right here. That's our first point. All right, the next thing I need is the slope. So what's the slope on this line here? 2, which means I need to do what? There it is. Go up 2 over 1, up 2 over 1, up 2 over 1. Remember, the more points we have, the better our line's going to be. I'll also get a couple of points down here by going down 2, 1 to the left, down 2, 1 to the left. Now do me a favor, before you connect those dots, I want you to go ahead and list some of those ordered pairs in this first table for me. For example, one of the ordered pairs I have here is 0, -4. I also have another ordered pair here, 1, -2. I also have the ordered pair 2, 0, and so on and so on. So what I want you to do is list those points that you've just plotted. Put them in that first table for me. After you listed those points, connect the dots, and that is the line y equals 2x minus 4. All right, so at this point, all we've done is taken the function, graphed it, and created a table of values from that function. Now we're going to take this a step further, and we're going to get the inverse of this function. So I'm going to help you to get started here. In order to find the inverse, the first thing we're going to have to do is take this equation, take the x and the y, and switch it. So now I have x equals 2y minus 4. And what I'm going to do is I'm going to solve for y. So I'm going to need help solving for y. So be ready. I'm going to be asking some questions. All right, so we got x is equal to 2y minus 4. The first thing I need to know is, what do I do first? All right, so Christina, what do I need to do first? I want y by itself. So what do I do first? Remove what? I want this y right here to be all by itself. I'll give you 4 choices. You can add, subtract, multiply, or divide. Those are your 4 choices. What am I going to do first? Subtract. No. Let's get somebody else. Veronica, help her out. What are we going to do? No. Let's get somebody else. Heather. We're going to add 4. The opposite of subtracting 4 is add 4. So now what I'm going to end up with is x plus 4 is equal to a 2y. We're solving for x. This is stuff that you did back in Algebra 1. We're not quite done yet. Not quite yet. Now what I need to do is get that y by itself. So here we go. Christina, what am I going to do next? I want to get rid of that 2. What am I going to do to get rid of that 2? I'll better your odds here. You're either going to multiply or you're going to divide by 2. Those are your 2 options. What are we going to do? There it is. Divide by 2. The opposite of multiplying by 2 is dividing by 2. Now notice when I say divide by 2, we're dividing everything by 2. Now, there is a number in front of the x, you just can't see it. Anybody know the number in front of the x? 1. So 1. So what do you get when you take 1 and you divide it by 2? 0.5, which is the same thing as 1/2. I'll leave it as 1/2. What about the 4 over here? What do you get when you take 4 divided by 2? 2. And of course over here you're left with just the y. So in other words, our new equation is y equals 1/2 x plus 2. This is what we call the inverse. That is the inverse of this right here. So think about it. If I'm saying that this is the inverse of this, when I take this equation, I come over here and graph it. Don't say it out loud because I'm going to ask somebody here. When I come over here and graph it, what should I notice in the graphs? What are we going to notice? I'm going to take this y equals 1/2 x plus 2, and I'm going to put it over here on this graph paper. What's going to happen? What are we going to notice? It's an inverse. What? A reflection across what? There we go. We're going to see a reflection across the line y equals x, or at least that's what should happen. Let's see. Let's graph it. 2. That's our y-intercept. So let's start right there, 2. 1/2. That's our slope. So let's come over here and go up 1, over 2. Up 1, over 2. Up 1, over 2. Get a couple more points over here by going down 1 to the left. Down 1 to the left. I'm going to connect these dots. He said that I'm going to see a reflection across that line y equals x. So let me go ahead and draw that line. Is that right? Are we seeing a reflection across that line? Yes, sir, we sure are. That's exactly what we're seeing here. All right, so let me take this one step further. If I'm seeing a reflection across this line y equals x beneath them, what should I notice about the tables over here? The flip. All right, so for example, instead of 0, -4, now the ordered pair is -4, 0. Instead of 1, -2, now I have -2, 1. So all the x and y values are switched, because we are talking about an inverse. All right, let's go to the next one. Sorry, go to the next one here. Now, I'll tell you what, we're starting to run low on time here. There is one other thing that I need you guys to do, so I'm going to kind of speed things up and skip some things. What we're going to do is, instead of graphing it and giving the table like we did earlier, I'm going to jump straight to finding the inverse of this thing, okay? So what I'm going to do is take the x and the y and have those guys trade places. Let's start there. There it is. Well, because we're finding the inverse. And that's the whole idea behind inverse, switching the x and the y. All right, so what I need to do is I need to solve for y. So there's 2 steps that I'm going to need to go through. All right, so Veronica, you're going to help me out on this first step, okay? What do I need to do first if I want to get y by itself? I'll give you 4 choices. Add, subtract, multiply, or divide. Those are your 4 choices. Subtract. And what are we going to subtract? There it is. We're going to subtract 1. So now what we have is x minus 1 equals 1/3 y. Of course, that's not the answer. We're not done yet. There's still one more thing I've got to do. Okay? All right, so Mike, what's the last thing I got to do if I want to get y by itself? Huh? Divide by what? Huh? Actually, that is correct. We could divide by 1/3. However, it's kind of difficult to divide by a fraction. So what I suggest instead is to multiply by 3, which is that 1/3 flipped upside down. But technically, you're not wrong there. Okay? Now, just keep in mind that we're multiplying the whole side over here by 3, which means you're going to have to use some distributive property. So 3 times x is 3x. 3 times the 1 is 3. Of course, over here, all we're left with is our y. So what we have is a new equation. And that new equation is 3x minus 3. We call this the inverse of this over here. So what's going to happen if I graph these two on the graph paper? What am I going to see? A reflection across the y equals x. What am I going to notice in the tables? We're going to notice that the x and y values are switched. Okay? So we're going to stop with the notes there. That doesn't mean we're done though. Yeah.
Like on this one, you have a fraction, it's 1/3. The opposite of that is, it's 1/3, so the opposite